Good afternoon. Once again, this is Mrs. Teresita B. Moreno. Welcome back again to my channel. Let's have a review of how do we identify ions and isotopes. So when we talk about atoms, we are referring to the number of protons in an atom, which determines the identity of the atom. So it simply means that the atomic number is equal to the number of protons. So they are similar or they are equal. So in neutral atom, for example, the number of positive protons equal to the number of negative electrons. So in short, number of protons is equal to the number of electrons. And we also said in the first statement that atomic number is equal to the number of protons. So that simply means the three are similar. Atomic number, protons, and electrons are equal. So protons and neutrons both have an atomic mass unit of 1, while the mass of the electron is negligible compared to the mass of the protons and neutrons. Okay, thus the number or the mass of the atom is the sum of the number of protons and neutrons. So what does it mean? As I mentioned in our previous discussion, mass number is equal to the number of protons plus the number of neutrons. Okay, since the mass number or the atomic weight or the atomic mass is equal to the number of protons and neutrons. So that is inside the nucleus. Here is an example of the subatomic particles. When I say subatomic particles, we are referring to the number of atoms, the atomic number, the mass number, number of protons, the number of electrons, and the number of neutrons. So I have here an sample of selenium. Okay, selenium, the given is neutron is 45. So if you are going to look at your periodic table, selenium is, the symbol is Se. So the atomic number is 34. So if the atomic number is 34, therefore, the number of protons, di ba kasi sabi natin, atomic number is equal to the number of protons equal to the number of electrons. So they are equal to the number of protons and the number of electrons. How do we get the mass number 79? So we'll just simply add protons plus neutron equals the mass number. I hope that's clear. That's for the subatomic particles. Okay, second example. The mass number is 222. The protons is 86. So therefore, the electrons is 86. And the atomic number is 86. Now, you have already the mass number and the atomic number, the number of protons, and the number of electrons. How do we know the number of neutrons? By simply subtracting 222 minus protons, which is 86. That give you 136. And if you are going to locate the atomic number 86, the element to be found is radon. So the symbol for radon is Rn. Okay, third example, we have electrons is 51. So if that is 51, the protons is also 51. Atomic number is also 51. Now, given already the neutrons and the protons, can we now get the mass? Yes, very good. We can get the mass by just simply adding neutron plus protons that give you 122. Now, check your periodic table. What is element number 51? Element number 51 is antimony. And antimony has a symbol of Sb. Last example. Atomic number is 11. Electron is 11. So therefore, the protons is 11. So what would be the mass number? Okay, since we don't have neutrons. Maybe you can check your periodic table. What is element number 11? Definitely that is sodium. So sodium has a mass number of 23. Now, if you are going to check your periodic table, it is not written in a whole number. So what you are going to do is round off the numbers given there into a whole number. That's why you have 23. So what will be the neutrons? Just subtract 23 minus protons. That give you 12. So our element is sodium, has a symbol of Na. So I hope you still refresh on the subatomic particles. Okay. Okay, next is isotopes. How do we know, or how do we identify whether it is isotope? Okay, the number of neutrons in any specific type of atom can vary. Atoms of the same element with different numbers of neutrons are called isotopes. So in short, what varies is only the number of neutrons and the mass, the atomic mass. But the others are still the same. Okay, isotopes are distinguished from each other by including the mass with the name or symbol. Okay, let's have an example of isotope. So as mentioned, isotopes are similar elements with different neutrons and mass number. So we have here an example, uranium-235. So the atomic number is 92. So therefore, the number of protons is also 92. Can we now get the mass? Yes. The mass will be by adding 92 plus 143. That gives you 235. Or just simply looking at the symbol where it contains the mass number. So what would be the number of electrons? Well, that is still 92. Now what about the name? How do you write the name for isotope? So the name for isotope, we have uranium-235. That is the proper way of writing isotope. Okay, the second example is 238 uranium. So what would be the mass number? You have 238. What about the atomic number? You have 92. So therefore, the number of protons is 92. The electrons is 92. And the number of neutrons, just subtract 238 minus 92. That gives you 146. So what's the name? That's uranium-238. Okay, let's have the third example, carbon-12. So in symbol, you have carbon-12. So what would be the mass? The mass is 12. So what would be the atomic number of carbon? Can you check your periodic table? Okay, very good. So that is 6. So the atomic number is 6. So therefore, the protons is 6. Then the electrons is 6. And neutron is also 6. So how do we get 6? Just subtract mass number 12 minus protons, which is 6. So the answer is 6. Okay, last example, you have carbon-13. So carbon-13 is, the mass number is 13. So atomic number of carbon is 6. So how do you write the symbol? You have C13. Atomic number is 6. Then you have the number of protons is 6. Then neutrons is 7. See? And electrons is 6. Now, if you are going to look at the example, what differs is the mass number and the neutrons. Look at uranium-235. The mass number is 235 and 238. The neutrons of the first one is 143, while the second one is 146. For for carbon 12 and carbon 13, the mass differs. Okay, the other one is 12 and carbon 13 is 13, while the neutrons is 6 and the neutron for carbon 13 is 7. So that is isotopes. Okay, next. What about ions? When do you say it is an ion? When I say ions, these are, diba, in the neutral atoms, the number of protons and the number of electrons is equal. But in the case of ions, it differs. Okay? So, remember in mathematics, when it is positive, meaning there is an additional. When it is negative, there is a reduction. But here in ions, it's a very different thing. When it is positive, that means there is a deduction of, or there is losing. But if it is negative, there is an added or additional or gaining. So remember that. Okay? So atoms can gain or lose electrons to become ions. So ions are charged atoms resulting from the difference in number of positive protons and negative electrons. So what will be affected here is the electrons. Okay, if it is positive ion, that is cation ions. A cation ion results when an atom loses electrons. Oh, you see? If it is positive, electron is losing, or there is removal of electrons. So therefore, the number of protons is greater than the number of electrons. Another one is anion. So anion is a negative ions. An ion results when atom gains electrons. So therefore, electrons is greater than the number of protons. So remember, cation is positive, anion is negative. Okay, ions are distinguished from atoms by including the ion charge as a superscript in the symbol. Okay, that's why you can see in the periodic table that there are positive 1 or negative 1, positive 2, or negative 2. And there are also elements with different or plenty of ions. Okay. So let's have an example. The given example is aluminum positive 3 ions. So what would be the atomic number of aluminum? So that's the name first, aluminum ion. And then the atomic number is 13. So if the atomic number is 13, what would be the number of protons is also 13. So what about the mass number? Look at your periodic table. Period 2, group number 3, aluminum. So the mass number is 27. So how do we know the number of neutrons? By simply subtracting 27 minus 13, that gives you 14. So what about the electrons? So electrons now will be affected since it is positive charge. So when it is positive charge, therefore there is a reduction of electrons. So instead that it is 13, that becomes 10. So is it a cation or an ion? Okay, very good. That is cation since it is a positively charged ion. Okay, next example is iron. Ion. So iron can be or is located in, where is Fe? Okay, located in group period 4. Okay, that's group number, okay, that's in the late transition metals. Okay, Okay, group 6, group 7. Yes, group 7 in late transition metals. So what would be, the mass number is 56, so the electrons is 24. So look at the atomic number of iron. So the atomic number of iron is 26, but the electrons is 24. So therefore, the protons is still the same, 26. To get the neutrals, subtract 56 minus 26. That gives you 30. So what would be the charge? What's the difference between 26 and 24? Okay, there's a difference of 2. Is there addition or subtraction? Okay, very good. There is reduction of 2. So therefore, it is iron or Fe to positive. So that's a positive ion. So therefore, it is a cation ion. Okay, next example. The protons is 15, neutron is 16, electrons is 18. So what will be the atomic number? It is 15. Can we now get the mass? Yes, we can. Just add protons plus neutron. That gives you 31. Now, look at protons and electrons. Okay, what's the difference between 15 and 18? Okay, very good. There is a reduction. There is a difference of 3. Is it increasing or decreasing? Well, that is increasing. So therefore, there is an additional 3 electrons. So therefore, it is P3 negative. So that is negative ions. So when it is a negative ion, so therefore, it is phosphorus ion. Is it a cation ion or an ion? Okay, very good. That is an ion since it is a negatively charged. Okay, last example. You have fluorine, negative 1. Ions of negative 1. So the protons is 9. So therefore, the atomic number is also 9. So what about the neutrons? Okay, by just simply subtracting 19 minus proton is equal to 10. And there is negative 1. So what will happen to the electrons? Is there an addition or a reduction? Okay, very good. There is an increase or addition of 1. So 9 becomes 10. And what will be the name of the ion? That is fluorine ion. So I hope you can now identify or visualize when to say that it is ion and a cation ion. When it is positively charged, there is reduction of electrons. But if it is negatively charged, there is an additional electrons. Remember that. If it is negatively charged, an ion. Positively charged, cation ions. Now, okay, there are some ions that we say that it is monoatomic ions. When I say monoatomic ions, there is no other ions present. So, halimbawa, sodium is only positive 1, magnesium is 2 positive, iron is 3 positive, okay, sulfur 2 negative, chlorine negative 1. But there are also ions that we said it is polyatomic ions. Now, if you check your periodic table below, where is it? Okay, this one. Okay, these are the polyatomic ions with negatively charged and positively charged. Meron dyan nakalagay sa taas, may nakalagay dyan sa heading na cation ion at anions, which is a polyatomic ions. When I say polyatomic ions, it consists with 2 or more elements present. Okay, just like phosphate, PO4 3 negative. Okay. Okay, another one is transition metals. That is in group 1B and to 8B. So in most transition metals, there are plenty of charges. Sometimes there are 2 or more charges. So when the ion with lower charge, it will end up with OUS. If it is with higher charge, it ends with IC or IC. Now look at your periodic table. Transition metals. Where can we find transition metals? It is okay, transition metals yung mga nandito. Yan, dito. So, makikita mo dyan sa label. Label ng iyong periodic table. May mga nakalagay dyan, transition metals. Whether it is early transition metals or late transition metals. Okay, for example, metals with more than one ion. Okay, ito yung mga example natin. Okay, arsenic positive 3, arsenic positive 5. So, the stock name is arsenic, then you write the charge in a parenthesis and write them in Roman numerals. That's why you have arsenic 3, arsenic 5. So, Au positive, so understood that there is a unit of 1. Okay, gold. Gold 3 positive, gold 3. Now, what would be the classic name? Diba sabi natin kanina, when the charge is lower, it will end up OUS. If the charge is greater or higher, it will end up with IC or IC. So therefore, when we say arsenic 3, the classical name is arsenos. Arsenic 5, that is arsenic. Okay, what about gold? Gold, hindi goldus ha, that is aurus. Because there are some elements that are taken from the Greek name or the Greek term. Okay. So gold 3, that's auric. Now what about cobalt 2? Can you try? Okay, let's try. Cobalt 2 is cobalt 2. So what would be the classical name? I know. Sige, we'll start first with cobalt 2. Then you have cobalt 3. You have Cu, that is copper. Copper 1. You have copper 2. Cr is chromium. Chromium 2 and chromium 3. Now, if it is lower charge, it will end up with OUS. So that will be cobaltus. Then you have cobaltic. So what about copper? Hindi siya magiging copperus, huh? That will be cuprous. Okay. And then copper 2 will be cupric. Okay, chromium 2. Okay, can you guess what about chromium 2 and chromium 3? Okay, well, that is chromos and chromic. Okay, let's have another example. Okay, let's have another example. Okay, metals with more than one ion. Maybe you can try this. You write down the stock name and the classical name. Okay, let's see if you can correctly give the stock name and the classical name of the following. So I will leave you for that so that you can practice also giving name of these different ions. Sige. You can message me if you have your answers already. So let's proceed with non-metals. So for monoatomic anions, name by attaching the suffix IDE to the first few letters in the root word. For the polyatomic anions with lesser oxygen atoms ends with ITE. And with more than oxygen atoms ends with ATE. So paano yan? So mamaya I'll give you an example. So I'll give you an example of naming polyatomic anions. Okay, the first example is OH. So the name is hydroxide. Okay, CN is cyanide. We mentioned earlier that when there is lower oxygen, it will end up with ITE. If there are greater oxygen or higher oxygen, it will end up with ATE. So therefore, in the third example, that will be nitrite. So NO3, that will be nitrate. SO3, that will be sulfite. And SO4, that will be sulfate. Parang yun sa mga ferrous sulfate. Then you have PO3, that will be phosphite. And PO4, that will be phosphate. Now you can check that using your periodic table below. As I have mentioned, meron tayong mga polyatomic ions dyan. Dyan yung makikita yung mga different polyatomic ions and polyatomic anions. So in the example, these are all negatively charged. So therefore, it is anions. Now, for the halogen group, halogen can form 4 different polyatomic ions with oxygen. For example, if one atom of oxygen present, that will be hypochlorite. If there are 2 atoms, that becomes chlorite. If there are 3 atoms, that will be chlorate. And if there are 4 atoms of oxygen, that will be perchlorate. So that is for special cases among halogen group. Okay. Now, in naming some chemicals, usually we are using prefixes. Greek prefixes like mono, meaning 1, di, 2, tri is 3, tetra is 4, 5 penta, 6 hexa, then 7 is hepta, octa, and 9 is nona, and 10 is deca. Now, we'll be using these prefixes in the next session on naming and writing chemical formulas. So that's all for now, and I hope you learned something from our review for today with regards to ions and isotopes and naming some compounds, some anions and cations or the polyatomic ions, and also naming some elements with more than 1 ions, just like the transition metals. Okay. So thank you guys for listening again, and hope to see you in my next tutorial so that you will be equipped with, or you will be refreshed with the past lessons that you have taken when you were in grade 8, in grade 9, and in grade 10, so that in our discussions, coming discussions, you know already what to do, because these lessons and these topics, you'll be needing this in our future discussions. So thank you and happy listening. God bless and keep safe.